Every second, Cloudflare blocks millions of malicious requests. Some attacks exceed 1 terabyte per second. Yet, most websites behind Cloudflare never even notice. So, what actually happens between a hacker sending millions of requests and your backend staying alive? Today, we are going to reverse engineer Cloudflare's DDoS attack protection and then build a simplified version of ourselves. And why this is important, because as a backend engineer who can understand this type of criteria and they can build something like this, gives you an upper edge to actually visualize a system. And this would be a very good practice even if you are more into learning cybersecurity type stuff. So without further delay, let's change to our screen. Okay, very first thing first, that what is DDoS attack at the very first place. So a distributed denial of service, that like this is what DDoS is actually not, distributed denial of service attack, and when thousands of machines send requests simultaneously. What it means? So technically, let's suppose your website holds only 100 requests per second, right? Or maybe usually you used to see that there are 100 requests per second happening in the backend, usually on the normal days. Suddenly you felt there are around 1 lakh plus requests per second happening, which is very abnormal for you. Even like if there is no sales, there is nothing, no offer is going on. Let's suppose you are on an e-commerce website and there is no sale or nothing going to happen, then suddenly you see this much level of spike, suddenly 1 lakh requests per second. This is what a DDoS attack look like. So if I say here that the attacker actually have multiple bots, you can see even the bot have other bots, and it goes like the figure is ending here, but here could be possible that this one have 3 more CPUs and this have 3 more CPUs, and this is how attacker from a single computer handles multiple bots, and that multiple bots, like let's suppose 1 lakh bots, actually target to your one single server. So this is what DDoS attack looks like. This is how DDoS attacks happens. For the people who don't know what is DDoS attack, I had explained it. Now, why normal server fails under this circumstances, DDoS attacks happens. So I am going to talk about the very first normal flow. What is normal flow? How the system works behind the wall, right? How the servers work. So let's suppose the client from, like, it could be your front end of mobile app or web app. It's a front end. What it do? It creates a HTTP request at the very first, right? Then if you know this, there is always a load balancer in between. The load balancer do what? It could be Nginx or HA proxy or whatever load balancer you prefer, but let's suppose there is a load balancer behind it, and not let's suppose, it's usually there, right? The load balancer. Load balancer do one thing, that it distribute traffics, right? Let's suppose there are different backend servers. There is backend server A, backend server B, and ... backend server N. There are multiple backend servers for you. So typically load balancer just distributes the traffic, so that what happens, let's suppose one traffic go to server A, it do the SQL query, and this is read only, by the way, right? This is a read only, something happened and it went to primary database to write. Otherwise, other thing could be that it just want read only, they just want to read something from the database, it went to the replica database where only reading is allowed. And backend server B, what did is actually done some SQL query and went to the database layer, and it wrote something, right? Server B, it's supposed to do something and it did something, let's suppose is right, and it also updated the replication simply. And backend server A, it can do multiple things, again SQL query or read only. So it's upon the server, it can do anything. So you have multiple server, load balancer make sure that everything distributes for you, so that your backend, the computer, technically your server is your computer, right? Is a CPU, doesn't die under a lot of load. So this is how normal flow look like. But how? If you are saying, Akash, there is a load balancer which will make sure that every time my traffic comes, it distributes, then how it's supposed to actually make my server down? Yeah, you have a valid point. Let me explain you that as well. So let's come to the DDoS flow here, right? So what happens? There is an external traffic, we are not talking about it because we had already talked about in this flow that how normal traffic or external traffic look like. There we have DDoS attacker, right? It also went. So, these are the legitimate requests and there is a high volume request. So, when there is a high volume request, this is what infrastructure layer look like. There is a firewall service, it goes to the firewall service, both the requests come to this and then it goes to the load balance or the gateway. You can call it load balancer simply or gateway. So, here now, because of course, you can think our load balancer can't make decision that this is a legitimate request and this is a high volume request from the attacker itself. Otherwise, what happens? This request and this request just sum up, right? When this sum up, so technically all the pressure goes to the load balancer and then it goes to the like connection pool or it can go to the backend server. So, connection pool exhaustion. What is connection pool? These are the connection pools that I am talking about. There are multiple connections that is going on, right? So, technically your connection pool, it goes to the connection pool and all the pools are filled, like there is 1 lakh, let us suppose maybe 10 lakh around attacks is happening through the bot. So, 33 like 3 lakhs 30,000 around something on this server, 3 lakh 30,000 on this server, 3 lakh 30,000 to this server. So, technically all your pool get overwhelmed with this, all your pool goes overwhelmed. Now, what happened? The pool exhausted, or even if it reach backend server, let us suppose the CPU resources actually get 100% usage. So, technically if your computer do a lot of tasks, it reach to 100% and that makes the CPU go shut down. There is something happens in both of the cases that it goes to the system memory, right? And when it goes to the system memory exhaustion happens. Data layer, database management system, the DB, query overload. So, technically a query is running and the query is overload. When we say it's overloaded, when there are more than the sufficient requests we needed or more than the feasible request on the computer or on the CPU. So, because the CPU is 100%, but it sent all the pressure on the database, the query overloaded it and the database collapsed. So, technically there is no capacity here. So, there is nothing load balancer K2. So, you will get nothing out of it. So, here as the database collapse, you get nothing. You can't, the user is not going to get anything for the legitimate traffic. What is going to suppose happen? This. But now it's happened that database has collapsed. So, there is no database from where your server can query the data and there is nothing to give. This is what happens in the DDoS attack. So, conclusion is that you or maybe I am not saying you, but attacker sends more than enough traffic on the CPU and CPU send those queries to database and database get so much overwhelmed that it collapses in them. It's something like you are so much tired that you had a very heavy gym set today, you had went for all the PRs that you can have today and you did everything, and in the end what you felt that hey, my I probably need a sleep, I need sleep. So, this is what happened here. So, can we overcome this? Of course, we can overcome this. So, we have something called Cloudflares. So, we use Cloudflare for this type of work. So, how Cloudflare architecture works? So, it have total 3 layers in this. Let me talk about it. This is where the global internet lies, even your attacker's traffic, everything lies in this, right? So, end user or attacker, everyone goes to the same route. So, end users send multiple things, like even your attacker will send something. Here what happens, anycast routing, the first layer is anycast. What anycast do? It actually makes sure that your distribution of the request or response, the request only, the response get distributed across different data centers. So, Cloudflare have around 300 plus data centers. So, you can see the Anycast global network, we are calling it. The first layer is Anycast global network. So, very first thing what will happen, your anti-cast routing will make sure that, hey, the edge server, let's suppose there is a server in London, there is a server in Tokyo, there is a server in New York, and there is a server in Sydney. In this 4 edge server, the traffic got distributed at the very first level. Good enough, right? The very first thing, and this is happening before reaching to your load balancer. By the way, if I say you, if you are thinking, Akash, this is what load balancer was doing. No, yes, load balancer is doing this, but before reaching to load balancer, the distribution got more segregated. There is more distribution now to the traffic. So this is a first layer, by the way. We have 2 more layers where we are going to talk about, which will help you to understand how it's going to work and why this is very, very efficient. So very first thing, Cloudflare real traffic happening. Then second layer is edge filtering and security. This is where your CAPTCHA solving case comes. So what is do before reaching to CAPTCHA challenge, we have multiple layers that happens. First thing, IP reputation check. That is your IP is blacklisted or you don't have a valid IP reputation. So technically, in the networking, your IP have a reputation. The lesser the number, the more the bad it is. So you have to maintain a reputation. If you keep doing, how the reputation got affected? Let's suppose you keep sending traffic to ineligible places and at the mass level, then the reputation, then people mark that IP as a spammy IP. So where the reputation goes below. So first step, it checks the IP reputation. If your IP reputation is bad, then of course it will go to the rate limiting. Then from the IP reputation checking, let's suppose it's passed, it goes to rate limiting. Rate limiting do what? If you know, if there is 500 requests coming at a single time, and I know that the max on the average mean time, I only get 100 requests per second. But let's say ki suddenly I expect 500 requests per second, but it's 1000 requests per second suddenly. This is not I am expecting. So after 500 milliseconds, let's suppose there is a 500 millisecond gap. What will happen that the 501st reputation, 501st request will get blocked for, let's suppose, 15 to 30 seconds. So it can go around 1 minute as well. So it can happen start as well. So rate limiting, make sure that, hey, whatever you are doing, right, if it's 501st request and I have just put it that I can handle 500 requests per second, then on the 501st request second, it will block everything for next 1 minute, let's suppose. So it happened, and it was like, okay, it's feasible for me. The rating I'm getting 301 requests per second. Okay, this is feasible for me, for my server technically. So I go to the bot detection. Then in the bot detection, it goes to the Java CAPTCHA challenge. So for detecting a bot, you must have seen this a lot of time. That just a minute. So sorry, my bad. Oh yeah, I was saying that you have seen a lot of time your JavaScript CAPTCHA challenge is there. There's a hidden algorithm behind it. A lot of people say that it's gets solved on how your pointers move technically, if or maybe the images. So they have their own algorithm. So we are not going to talk about the JavaScript or CAPTCHA challenge algorithm here, but yeah, there is a CAPTCHA challenge. So here, if everything goes well, it passes. Right, it goes here. In case nothing works, it goes to the blocked or failed. So technically, if anything goes wrong, it can goes from here, it can goes back to here, it can goes back to here. There's some 501 error, 502 error you can expect. So it will give the error. But let's talk about even if it passed. There is a third and last layer, that is edge casing, which is very impressive. So if all the thing pass, technically the requests are supposedly correct. The requests are valid enough. Let me go a little more down. So now talk about this. So we have one thing that we do is content cached. Even Next.js do that on the server side, that the content got cached. So if the content is cached, we have two things, either yes. If yes, serve from cache. So this is an edge server. This is your backend server, by the way. This is where your backend application or server and database relies. So if there is no content, let's suppose what we call Redis mess. So there is a mess. Technically, mess means there is no data on the cache. So the cache goes, and there is no. If there is nothing, it will go to backend application server. It will cache the database and then update the cache. And there is something different. This is not related to this. This is like this happens once, and then it is interdependent. Like we don't need this. If the content is cache, it goes to the serve from cache. This is edge. We get data from here. So technically, if you are good enough to understand this, so if I say, let me do one more thing here. Let me take a pen to give you a bit more understanding regarding this. Let me take a pen here. So here what will happen? Let's suppose initially there was 1000 requests happened. Initially 1000 requests happened. So you can see that the content is cached here as per se. So there is only one request. There is only one request that reached to the server. Then what happened to the rest of the request? It went to edge server, which is this. This is where from the cache we are giving the data. So your server, instead of hitting 1000 requests, what it did, it just hit one request, and then the 999 requests were from the cache. Very impressive, because you had detected like 1000x, like approximately you had reduced 1000 times of request on your server by this method. Impressive enough, yes or no? So this is what Cloudflare do. This is about the system design that we talked about. Let's talk about the code part as well with me. So let's go on the code. So let me talk about here, as we understand how it's going to work. Let me give a simple board. Let's suppose call it board, and we will understand it here. Also let me zoom it, right, so that you can see what we are coding. So how the system should look like? The system will look like something like this, where what happens, the client goes to the edge server, right, the server where it's actually cached. It do the rate limiting, it does the IP blacklisting, it checks bot detection. If the bot detection is not found, but we are suspicious about this, what we do, we do give them a challenge. Okay, and then if things goes well, then we in the end we serve anything from the cache. In case there is nothing in the cache, then we go to the backend server. So understand it. What I will do, I will just simply first initiate. I will code it into Node.js. The logic would be same for every case. You can go in any language, but I am very comfortable in the JavaScript, so I am going to code it in JavaScript. But let's say I am going to initiate it. I will call it -y, and for the project, for this small project, I just need 3 different packages, only 3 packages that I will be requiring. But let's see, it happens here once. Okay, and then I will have 3 packages that I need npm install, and the 3 packages are express. I will need Redis for, of course, replicating the caching logic that I talked about, and the Axios. That's it. I will just need these 3 services here, and I will create a different file to actually replicate all of this thing. I will call it, I will create one file that is backend.javascript, and then I will create another file where we will do the edge server case, right, edge.js, and then we will talk about attack, like we want to replicate a attacker as well, so we will call attack.js. We will be trying to formulate that how it's going to attack, and Yeah, that's it. Let's start with this. So very first thing first, we need what? We need server. So let code server. Very simple. We won't keep it difficult. Const require express uh, app express and app.get simply, uh, and this is what I am going to get, and request response. Oh, request slash response. Why the hell it's happening? Response, right? No, it's working. Cool. Okay, okay, my bad. I have given dot here, and I want to actually make it more intrusive. So I will do one thing, that I will ask to actually give me a response.json, but in this JSON file I want a message first, that because I want to replicate that how it's working, right? So I will just say hello from backend, and then let's talk about time, right? We will give a time so that I can tell you that how it's working. It will make more sense. Then date dot now, and I will keep it as time here. Simple, done. Let's now app dot listen at around, my favorite number is 3000 when it comes to server. I will just keep it server, and simply this, and let me give you a message as well so that it says that hey, your server is working. Console.log service, server log, I will call it backend so that it will make sense. Okay, cool, done. Okay, now we have backend. Do we need to test? Let's test. Not backend.js. If my bad, backend.js, and you will see the backend will be working on port 3000. Okay, nice. What we need to do is actually doing attack. Let's create a attack script here, and this attack script will help us to determine how everything is working, right? So let's go on the attack, and let's say I will just say const axios, and it will require axios, and I will say I will just run a loop, right? For let 1000 will work, and I will just say I will just simply say that yeah, axios 10 response console.log dot catch error if there is console.log error. So basically I'm just talking about error. Okay, as we discussed that we had created one attack.javascript. This is very simple logic, that what I talk, that there is a single call that I keep creating for like 1000 times, and let me just run it here. I will do one thing, that I will run node and attack.js, and let's run, and let's see. It will take a bit of time, but you can see okay, it's completed, but you can see every time it's hitted with 1000 here for every new time. Pretty concerning. Let's go till what happens if I make it this. Although my app will crash, the attack itself will get crashed, but in normal environment you can imagine that this much level of request is surely gonna make that your backend dies, right? So let's see. I guess it's creating, it's requesting. It's such a big number that it's taking time. Though you can imagine, right, at this page. Okay, you can see here that okay, let me let me close it. Okay. And what is the error? So we got an error. It could be simply because the number is too big to even handle for the script itself, or maybe undefined 21 infinity max body length infinity uh, in a buffer. So we are getting something where the server blocked. We can imagine it right now at this, although it's working, maybe the script isn't able to handle it, but let's suppose this. Now let's create the other file, which is edge.javascript. So we have to do what? We have to do rate limiting, we have to do IP blacklisting, we have to do bot detection, we have to do challenge system, and we have to do edge cache, right? So let's work on the edge.javascript here. So before we go to the edge, what we will need is cache here. Cool. Let me run the cache. For the caching, I will just simply open my Docker. So basically I need Redis, right? So for that I am just creating I'm starting my Docker. When it gets started, yeah, it got started, right? So let's get started. I just create a Docker run, and I will say 6379 and 6379. I'm just creating my Redis. So let it find Redis. Let me pause the recording because it will take a bit of time. Okay, so as you can see, the Redis server has also started. I'm using Docker. You can use any other server if you have locally, and you can use that. Otherwise, cool, you can follow the same step that I did right now. So in the edge.javascript, very first thing that we are trying to do, although the caching part is pretty far, but let's do a simple edge server code. Let me just minimize it first, right? Okay, what I need, of course, I need Express. Yay, my cat also knows that I need Express. And then I will need Redis for the caching part, and require I have Redis, right? And then I will require Axios as usual. I need Axios, and simply, yeah, this is what I was talking, app the equals to express.javascript and Redis. I initiated both of this right file. So now, first thing first, let's come to the board again. What is the first thing I need? I need rate limiting. So let's do rate limiting first. I will create a function where I am talking about a async function, and I will call first check I want to do is rate limit. I will just rate limit that, hey, it's not possible that you go with, I say, like, you can't skip this. I want rate limiting. I will do the rate limiting, and what the rate limiting will look like, that I will have a key, right? The key do what is actually I will rate, and then the key is rate, and I want to do that I will store the IP address, whatever the IP address I am getting, right, from the rate limit. So this is what I am storing, rate IP, and then I will just const, and I will count the every time there is a request, it means +1 from the same IP. If I am getting it from the same IP, I will just increase the count. So I will show you a small diagram here, that what it is happening here, what is happening here, right? This and that increment, and there is key. And so basically what I am doing, let's suppose try to understand this in this table here. In this table, if you see, I will have a table here, and let's suppose the IP address, like this IP address 1 exists. I have this IP address 1, right, and 1, and then if, and there could be multiple IP addresses as well. Let's call this and this. If my IP address is 2, if my IP address is, let's say, 3, and if my IP address is 4, what will happen here, that I will have also the count. Let's suppose my IP address is 1 across all of this field. And then there is 1, and there is 1, and there is 1 to all these 4 IP addresses. If, let's say, if one more request came from this IP address 1, it will go to 2. I will increase the count. If it again come to 3, again some another request from the same IP, I will do it 3. If something comes 4, let's suppose it's keep increasing. I want that after 10 requests, you are not allowed to make a request in this particular second. Like let's suppose there is a time interval of 30 seconds. I don't want you to actually make any request, and after you can make 10 requests in 30 seconds from a single IP request. So this is what I am talking about. So this is how what you are storing in the Redis. You are storing the IP address and the count, that how many times you want to make sure that, hey, my IP address will get stored. Cool. So if the count equals to 1, if I am saying that the count equals 1, I will do one thing. I will await, and I will say Redis dot expire, and here I am giving a time to live to the key. So let's suppose there is a count is 1 and the time to live is around 10 seconds. For now we are going to keep it 10 seconds. So yeah, I want that it will expire in 10 seconds itself. Redis await. Cool. What I made some mistake here. Okay, I made a mistake before, but yeah, it's now okay. If what happens suddenly that mic? Okay, so what I did, I made something that if the count is 1, just expire it in 10 seconds. Simple. If the count is greater than 20, return false. So if the count in, let's suppose in 10 seconds, let's say we are talking about 10 seconds here, if the request in the first 10 seconds is more than 20, I want to just return false. I don't want anything else. Otherwise, it will just return true. Cool. So what I did, I put it a rate limit to this. Let's suppose it got done. It's somewhere. We get key. Okay, it's working fine. Let's do one thing. Now, if the rate limit is passed, so I will say, I will put a tick here. I had wrote a logic for a rate limiting. Cool. Now let's talk about IP blacklist. I want to do the, I want to check is the IP is blacklisted. So I will just say async, again async function, and I will say not fetch data. I will say is blacklisted, and the argument would be as typical as IP. Cool. Now let's write the logic for this function. I want to say that const if the result is simple, that await, and I want this from the Redis itself, that hey Redis, tell me that whatever I have got is the blacklist. If the key is blacklist, and the IP should be right. If result doesn't give this, then return true. Otherwise, return result true. If the blacklisting is not here, if the IP address is not blacklisted, then go for else. The result should be true. if we get a blacklisted IP, then this is an issue. Now the question would be how we are going to blacklist an IP simply. So let's write one more logic here. What's the problem here? So now the logic would be for add something, add function, and I will call blacklist IP, and simply I will just say that await redis.set. The function was written by AI itself, blacklist IP, and the expression will be true, and expiry, there would be an expiry, let's keep it for 300, so 600, like this is around 1 hour. I want to keep it like 1 hour or 10 minutes, I guess it's 10 minutes. So for the next 10 minutes, the IP will be blacklisted. We had given true, that it's blacklisted and it will return true, but also there would be an expiry we are talking about, that is for the 3600, the time to live. So after 3600 seconds, the blacklist will get removed. So we have two functions. This two function do what? It completes this function, that is IP blacklisting. We have done with the IP blacklisting. Now let's talk about the bot detection here. I just need bot detection. So I will write function and I will call detect bot, and I will say request, and I will ask. So there is something called user agent, right? So we are going to talk about, for the bot detection we check user agent. So this is a fundamental networking concept that we are talking about, request.headers. The user agents are usually stored in the headers file, and here I will check, is the user agent headers in user agent, I will check user agent, or it will be empty. If oh sorry, my bad, I'm just talking about that I want to fetch this from the headers user agent, I am fetching this. Okay, if I have few conditions, if UA include code, or UA include bot, if UA include scrapper, let's say, if the user agent have, like, usually it's not there, but for making this the scenario workable for us, we are saying that if the user agent includes scrapper, right, then we are talking about return true. Otherwise, if something like this exists in the user expression, just return true, otherwise return false. Cool. So normal browser do what? They give us user agent. If there is a bot, there would be a UA which includes something like this. Usually the Cloudflare engineers research about this. There is a complete team of cybersecurity and analysts or something like that. They keep looking into the user agent, but right now we are talking about that maybe we have a user agent that we have indexally. So it will, if it's returned true, either it will return false. Now we have to put CAPTCHA, right? We have done with the one thing more, that is bot detection. We have figured out that okay, bot detection is done as well. Now let's talk about challenge test. Okay, I will do one small thing, that I will create for making it simple, I will just do one thing, captcha.html, and I will just put this. I have a small code, I am just saying that is to security check type whatever, and form method will be get action verify, something like this. We have just done something, and let me write this. Okay, so we have just a simple form which asks for that, hey, verify if input in the input answer, and let's make a captcha. So usually it's not that simple, but for now let's write this. I will do one thing, I will add this into the route, that app.get. As you can remember, the HTML return and it's hit a verify button, verify, and a sync request response. In this I will just say that const answer equals to whatever request dot query dot answer. We are just putting this into the answer. I want this in the answer itself, and then const I want to store the IP address as usual. I will keep a track of the IP always. It's important to keep a track of the IP. And then if answer equals to not 42, let's say if the answer is to 10, we get the param query as answer 10. Then we will again call our Redis and Redis dot set. I will call it verified IP, and I will expire it in 600 seconds for now. So technically I am just saying that, hey, if the answer is 10, then the IP is verified and it's true, and expiry is in 600 seconds. Cool. And then send response dot sent. I am just saying that response was sent. That is verification successful, right? Verification successful, simple. And then else we have verification failed. That's it. That's all we have to do. And then this function is done as well. So now we had also achieved challenge system, and now the last thing remains is the edge case. Okay, so now first I forgot to do something, that is as I had written as I had given this a route, I want to talk about async function, because I want to do one thing is verified IP, and I will just const result get verified IP. If its return result is true, that's it. This is verified IP. Now it's not as per the board. Challenge system is also done. Let's come to the another part, that is what? Okay, return true, and then we will make a small CDN for us, cloud distributed network. CDN, cloud distributed network. Okay, whatever. Okay, let's go to this, and now we will, because on the last thing we just edge cache, we had the edge cloud, which means it will have the result or not. So it's very simple, async function, and I just say that get cache. I just want that if the data is there or not. Simple as that. And I just get cache const data. If there is a data, await redis.get. If there is no data, so there is one more flow we had discussed here, if you remember. As per this flow, if there is no data, it will return to the server and it will take the data itself. If there is no data, return null, right? And then we will say return JSON.parse data. So technically I am just asking cache to actually return me the data. Simple. And also I want to store the data, so I will write one more function, async function set cache, and the value I will just I don't want to give so much of complicated thing. I just want to say that key and the value data that I just need. So if there is no data, return null, and if the data is null, okay. Sometimes the AI does make my await redis.set, and I am talking about here key JSON, the answer, that what I want, right? The data, stringified data, simple. I just want the data and expire, and let's call it 30 for now. In every 30 it will expire and it will again reheat, because there could be a possibility that data is not there or data has been updated. And this, in this way I will just done, and I will use this edge.js. I will create a middleware. If you know this middleware, right? I will create the middleware in itself. So these are the whole logic that I talked about. Now let's talk about the middleware that will make sure that this whole thing happens. Use async request response and next, and then I will just say, yeah, I want request IP. I got the IP, right? If what is the first thing that I want to check? IP blacklist, right? Let's first check the IP blacklist. If blacklisted, return you are blacklisted. 403. Simple. Very simple to understand. Okay, let me do one more thing. I will put this again here so that it's easier now. Cool. I done this. Now const allowed. If the blacklisting is done, allowed equals to await and rate limit. I want to check the rate limit, right? The function that we had written, rate limit. We just rate limited it, and now what we will do is if not allowed, if there is not allowed, if we are allowed, then rate limit, we add the rate limit for, you remember the logic, right? Await blacklist IP. In case the allowed is not here, then blacklist IP. As we talked, that how we are going to add the list blacklisted IP. We have a record for that. This is why we created this function blacklist IP. So technically we just blacklisted the IP if it's not allowed. Simple. And if it's done as well, if detect bot, I will keep it till here. I don't want this function. Let's call it if detect bot. If detect bot, I want to do one thing. If not allow await verified is not verified IP, return response, please verify you are human by visiting. So okay, let's not do this. Let me do one more simple thing. If is not verified, I will just do one simple thing, is respond dot send file, right? Response dot send file, and in this I will just say directory name plus verify dot html. Simple. Declaration of statement existed. Okay, and then this, and yeah, we are done. And if this whole thing done, if this whole thing does make sense, will be here, right? If whole thing is successfully done, then it goes to next. So we had created a middleware which checks from all of these things. Simple. So it will do one thing, that now the flow would be like this. It request arrives, check blacklist, check rate limit. If the rate limit is not hit, detect bot, challenge if needed, and then continue. Simple. And now what we will do, we will just put the backend in this way, where I just talk about async request response. I just add this code, which is okay. So now in this previous code, in this again backend.javascript, I will do one simple thing, response or JSON, and in this I just want to const cache key, and in this I will just save it into the cache. Cache, and in this, in case there is no cache, and I will do what, const cached equal to await get cache. In case we have the cache data, just cache key. If cached, we do have a sync. Okay, there was no sync. If cached, I want to make sure that it's cached, right, to console.log, and then I will just say cache it. If not, then console.log cache miss. So it gives us the sense of idea that if there is data in the cache, it will hit, otherwise it will miss. Simple, right? And then we have our this thing where we call, what we call is okay, my bad. What I had done right now is something that I have to do it for. Okay, what I had done now is not needed here. I just realize it. Just have to cache. You remember we used, so this is a small mistake I made. I have to do it in the edge server because we are doing it in the edge itself. We don't need anything else. So yeah, console.log, and then what we will do, we will just call const response await, okay, 3000, right, simply what we were having at that point of time, localhost 3000, and simple, yeah, done. Now we just have to await and set cache response.data and then response.body, and we are done. What happened now? Declaration of the statement unexpected. Oh, my bad. I just need this from here. So now what will happen here? I want to add this. I will call it on 3001 because on 4000 on 3000 our normal server is running, right? Node PowerShell. Yeah, server is running on 3000 already. Now what I will do, I will just simply start our node edge.js, not edge.js, right? So the public IP is never shown. Cool. I will do one more thing. If you see, if I will open my command prompt here so that I can show you simply that what will happen when I hit the edge server. So this is where it comes to engineering handy, curl.exe, and I just call http localhost, and I will just call 3001 because I am calling 3001. You can see. I just needed no such file, verify.captcha.html. Oh my bad. I just did one thing wrong here, is that on the edge, if I come here, I will don't call it captcha, I will call it captcha. Sorry, I won't call it. Now let's do it again. I have to stop and I have to start again. Now I will hit the edge server from where the data will come. Security, okay, and we have returned something like this where I have to do the security check, right? Now I don't want to do security check. What I will do is simply okay. So the interesting thing that I forgot to actually mention you, that you can see there is what we are using curl. So this is why we are getting blocked. As you remember, we are getting this because we are getting this curl. Let me comment this out, let's say, for now. And now again, let's run the edge. Let's see now how it's performed. You can see hello from backend. Cool, it's working. This is what it shows, that the bot detection is working, right? But what I will do simply that for now I want to get it done, right? I will just keep verify, as you remember the query, and I will call verify, and if you remember, verify equals to 10. If I do it again, verification successful. I got the verification successful, but for now it's done. So what I wanted to mention you that how it's working, how bot detection is working and everything. So we are getting blocked. This is a sign that the system that we thought of, that reverse engineer, worked for us. Now let's do one thing, that let's go into the attack.js, and for this let's call it 3001 and response.data, and in case console.log, if there is an error, we will response. Okay, I will just call blocked. Blocked, right? We'll just call it blocked, simple. Now do one thing, let's run the let's keep it 1000, save, and let's now run this node attack.js. Blocked. You can see that we got blocked because we have so much of call. So simply it worked on the rate limiting, and then after the rate limiting has returned, we got something, and then yeah, this is the answer that we have to get. Right, to you it just made sense. Cool. You can see it got blocked. This is what happens. This is how Cloudflare works in general. Not this is a way of telling you that hey, how simply we can make it, but this is not that simple. We just reverse engineer how Cloudflare would be doing this. The actual industry level standard are pretty different, but this made, I hope this video made you understand very critical topics. It given you a new idea, given you how other things works around. So if you like this video, do make sure you subscribe to my channel, because I will keep creating content where you don't sound like another crud backend engineer. I am talking about being more advanced or intermediate at least, and you will learn straight from someone who is building something from scratch, like who used to build something from scratch and doing it again, ABB, on industry standards. Share this with your friends who want to check out this video and check out this channel. And yeah, that's it. Please make sure you drop a like, and also do make sure that you drop comment if you want another video to be suggest your next video topic that I should make videos on. Thank you everyone.